The Elements of Non-Euclidean Geometry by D.M.Y. Sommerville.
Chapter 2, Elementary Hyperbolic Geometry. Section 27, the Parallel Angle. We can apply this now to find the value of the parallel angle pi of p by means of p. This is the simplest case of the determination of the relations between the sides and angles of a triangle. The triangle in this case has two sides infinite, one angle right and another angle 0. Let A gamma be parallel to B gamma and AB perpendicular to B gamma, figure 30. Erect a perpendicular at A to the plane AB gamma. Draw the parallels B omega and gamma omega. Draw the horosphere with center at infinity omega and passing through A, and let it cut B omega in B prime and gamma omega in C prime. Let B prime be equal to Y, and the arcs B prime, C prime A B prime, be labeled A, B, C. Since B gamma is perpendicular to AB, the plane omega B gamma is perpendicular to the plane omega AB. And since the angles, which are the arcs AB prime, B prime, C prime A, make with the lines omega A, omega B, omega C prime, are all right, the angle C prime A, B prime is equal to the angle gamma A, B is equal to the parallel angle pi of p. The angle A, B prime, C prime is equal to pi over 2. And since geometry on the horosphere is Euclidean, the angle A, C prime, B prime is equal to pi over 2 minus the parallel angle pi of p. Hence, the sine of the parallel angle of p is equal to A divided by b, and the cosine of the parallel angle of p is equal to C divided by b. Therefore, the tangent of 1/2 the parallel angle of p is equal to A divided by the quantity b plus c. The arc of the horocycle B is a standard length, namely, the length of the arc, which is such that the tangent at one extremity is parallel to the radius at the other extremity. In figure 30, BK is such an arc and equal to B. Hence, B divided by A is equal to e to the y divided by k power. Now fold the plane omega A gamma about omega A until it lies in the plane omega AB, figure 31. Draw gamma B double prime perpendicular to B omega. Then if we draw the horocycle arc B double prime C double prime with center omega, this arc is equal B. Also, B double prime is equal to P, therefore B prime B double prime is equal to P minus Y. Therefore, B plus C divided by B is equal to e raised to the power the quantity P minus Y divided by K. Hence, multiplying equation 2 and equation 3 and using equation 1, we have the tangent of 1/2 the parallel angle of P is equal to e to the minus P over K power. This relation may be put into other forms. For instance, the cotangent of the parallel angle of P is equal to the hyperbolic sine of P over K. Other equivalent forms can be read off from the accompanying figure, figure 32, treating the figure as a Euclidean triangle. We shall effect a simplification by taking in the following paragraphs, section 28 through 37, the constant K as the unit length. The formulae may be restored in their general form by dividing by K every letter which represents a length.
The Elements of Non-Euclidean Geometry. This book was written by D.M.Y. Sommerville, M.A. and Doctor of Science. It was published by the Open Court Publishing Company, London, G. Bell & Sons, Ltd. in 1919, and now is in the public domain. It is being read by Jim Renholt, with programming and illustrations by Jim Renholt in 2019. Thank you for listening.